Hello students, in this video lesson I would be doing question number 7 from exercise 7.1, and at the end you could have a look at some of the homework questions that I've given for practice. Please make a note of this. Question number 7 from exercise 7.1 is a very important question. Now it is given that in this diagram AB is a line segment and P is the midpoint of AB. Now, if P is a midpoint of AB, AP will be congruent to BP. Also, they have mentioned that angle BAD, that is this angle, is congruent to angle ABE, that is this angle. Also, these two angles are congruent. And this is what you need to prove. There are two things you need to prove in this. That is, triangle DAP is congruent to triangle EBP and AD is equal to BE. Now, if you look at this diagram very carefully, there are two triangles infused, right? So what we will do is, I'm going to separate these two triangles. So when you separate the two triangles, this is how it's going to look, okay? Wherein A is shown congruent to B. So A congruent to B. These two angles are congruent. But these two angles are not a part or not any element of this triangle. Because if you look at this angle, it is EPA. And this angle is DPB. So DPB you don't have out here, right? So what we are going to do is just put the indications which are known to us. That is this angle congruent to this. So A congruent to B as shown. And since it is mentioned that P is the midpoint of AB, I have shown PA is congruent to PB. So this is how the figure looks when you separate it out. And this two separate figures is shown for better understanding. So please make a note of this and draw this diagram, and in the rough you could also draw these two figures. So let us start with the proof. Now I have taken the two diagrams separately, where angle A is shown congruent to angle B, AP is shown congruent to BP. Okay. Now these two angles we have to prove congruent. So this is the entire figure. Let us begin with the proof. Now EPD is a common angle. Now look at this diagram. You will notice that this angle EPD with this yellow star that I have put, if I add it to angle APE, I will get angle APD. At the same time, this angle EPD, I am going to add it to angle BPD. So what do we get? Mention this. Angle EPA is congruent to angle DPB, which is shown by this indication. We will add angle DPE on both the sides. So when you add on both the sides, you get EPA plus DPE equal to DPB plus DPE. So after adding, what you get is this. Let us number this as statement 1. That means we have proved that DPA is congruent to angle EPB, the one shown in green. So this step is very important. Now, take the two triangles, that is triangle DPA and triangle EPB. You could also name the triangle like this. Write down the indications that have been shown to you. Angle DAP is congruent to angle EBP because it is given. They have given this angle is congruent to this. That is this congruent to this angle. So given. AP congruent to BP. Why? Because it is given. And we have just proved from statement 1 that angle DPA is congruent to angle EPB. Therefore, the two triangles become congruent by angle side angle. So ASA congruence rule. And if the two triangles are congruent by ASA rule, then write down the corresponding paths of congruent triangles. Therefore, AD becomes congruent to BE because of CPCT. So students, this is a very important proof. Two triangles are infused together. What you have to do is you have to separate them out. If you look at this light green triangle, it is an obtuse angle triangle which I've taken here, and the one here which is in blue is also an obtuse angle triangle. I've taken it out here. This indication and this indication in blue is already given. They have also mentioned that PA is congruent to PB, and the other indication given is these two angles. But if you look carefully, these two angles, that is EPA and DPB, are not the elements of these two triangles. So in order to make it the element, what we do is we will add this angle to both these angles. And then you get angle DPA congruent to angle EPB. That is this complete angle congruent to this complete angle. So it becomes angle side angle. I hope this problem is clear. Now in the next slide you could see some of the homework questions that I want you all to practice. Now this line segment AB is parallel to another line segment CD. And it is mentioned that O is the midpoint of AD. So it is shown by this sign that OD is congruent to OA. You have to prove the two triangles are congruent. Not only that, you also have to prove O is the midpoint of BC. So how would you do this? The clue given out here is the two lines are parallel. So if the two lines are parallel, you will take AD as the transversal, or you could even take BC as the transversal. Then you will get Z-shape angles, that is alternate angles. That means this angle CDO becomes congruent to angle BAO. So you have an angle. So you have angle, side, and you could take these two as vertically opposite angles. So you would get them congruent by ASA congruence rule. See if there is any other test of congruency. I want you to do this on your own. Write proper steps. The second question. AB is a line segment and line L is its perpendicular bisector. So as you can see, AB is a line segment and L is bisecting this side. Not only bisecting, it is also perpendicular. So what does that mean? It means that AC is congruent to BC. You have to show that P is equidistant from A and B. That means you have to prove PA is congruent to PB. In this, you have to prove P is equidistant from A and B. So in order to do that, you have to prove PA congruent to PB. If you prove PA equal to PB, it means P is at equal distance from A and B. So it is very simple. You will take these two triangles, you'll prove them congruent. Now, by which test of congruency? You have AC congruent to BC because L is the perpendicular bisector. So you have one S, one A, and isn't PC congruent to PC? It's a common side. So S, A, S. And therefore PA congruent to PB, They are the corresponding sides of congruent triangles. This is a very simple question. Indications have been given to you. You have to prove the two triangles congruent. So the test is SAS. Not only that, you have to prove AD parallel to BC. The clue out here is, in order to prove AD parallel to BC, write the corresponding parts of congruent triangles. Here you take the angles which are congruent. So look at Z-shape angles. So prove this angle is congruent to this angle. Then make a statement, but they are alternate angles, therefore the lines become parallel. Try to do this on your own. Question number 4. There are two triangles and they have given you the elements that are congruent. The two triangles are isosceles but not congruent, isosceles but congruent, congruent but not isosceles, neither congruent nor isosceles. Think over it. I want you to jot down all these questions in your geometry notebook, and in all the video lessons, homework has been given based on triangles. I hope you have completed the homework questions. Copy down these questions along with the diagram. Students, in the next video lesson, I have explained question number 8 from exercise 7.1, which is again a extremely important question. And along with that, I've also shown you all what all you need to study from this chapter. Okay, so until then, goodbye and take care.